Hello everyone. In this video, we'll see the selection sort. There are a lot of sorting algorithms are available, but selection sort is the easiest algorithm ever found in the sorting algorithm categories. There are more than 15 sorting algorithms out there. You can go through one by one. First, I have an initial setup of this array. There is an input array of randomized numbers. It's literally a non-repetitive and positive integer. It can be either positive or negative or repetitive or non-repetitive array. Here I have written the index of those arrays. Index starts from 0 and to 5 it's written, and we have a tabular setup because in selection sort, as the name suggests, you have to select an index when comparing from the current element. So I have this programming setup. It's nothing but you're just retrieving how many numbers you want to sort, and then you're getting that in an array and you're just printing, and then we'll write our sorting algorithm, and finally we'll print the output of a sorted array. Let me just explain this table setup. Here how sorting algorithm goes is each pass by pass. We know this is a tabular format, so we need a two for loop in order to use this kind of tables. Already it's been there. We have I and j like for loops. So what I'm doing is, here I'm declaring one for loop int and then size, and then here we have to write one more for loop for table structure int j. Here also I'm declaring size. Okay, later on this video we'll change this all variable and modify this, so we'll come back after this lecture. Okay, what the pass meant for is we have to scan this array and what element is lesser than the current element. Here the current element is denoted by I, which means I stands for the iterator, and here from first of the input I'll start, and the index is the element to be selected for swapping. What this selection sort is, what the selection criteria is, when you have one element called current element, you have to find out an element which is lesser than this current index, and if you find this element you have to swap it. This is what the whole sorting algorithm is. For example, this first pass I have 6 to this just the smallest one, that's like 2 4, you are finding on the way that that's 4, so it eligible for swapping. So you need to find out which is the smallest one which will become eligible for swapping. So what I'm doing is I'm taking this current element as I, and then I'm assigning to index. Then we have to compare that index through an index called j, which is after this number. We don't take this consider the elements before this, we'll consider the elements only after this. So what I'm doing is I'm giving the next number to I, which is I plus 1, so that I can take from 6 to 5. The next element is 5, so here it is 0, it is 1, 2, 3, 4 and 5. So from 0 to I will take I plus 1. Okay, I'm going here and I'm checking from whether here now what the condition is, j is I plus 1, so 0 plus 1, so it is 1. I'm comparing this one against this index. So is it greater? Yes, it's greater, but we'll keep it aside. We'll update that index. Here we have this element, so I'm writing here we have this index, and we have to update it. So we have this j. Here I'm updating. First pass, here it will be 1. So the array of 1, which is nothing but 5, and array of index is as of now what we have to assign is I. At first we have to assign it to I is nothing but 0. Now first pass it is 0. So what I'm doing is we are comparing this index, which means array of I and array of index I'm comparing, and if it is lesser I'll update this index as j. So I'll give j. So index having j. Now I'm moving next, which means I'm incrementing j. So j plus plus. Now the j value is 2, and then when I'm coming here to 2, you can see that 2 is 4, and I'm applying the same condition whether the index value and j's value is lesser. Compared to this, the j's value should be lesser. If that's the case, we have to assign that j to index. Yes, it's there, so I'll assign. For 2 also that's the same case, so I'll assign. So next number is 9. No, the actual current index is here, it is 3, which is literally the 3 index. So I'll not update it to 4 because it is higher than that. And next number I'll see, no, it is higher than 2, so the eligible index is 3. So what I do is I have to swap this 6 and 2. So literally I'll write the same thing as first pass. Here giving us 5, 4, 2, 9, and here 7. Here I have 6. I'll find out a minimum value, which means whatever we have seen so far, I'll find just minimum value and I'll pick that element and I'll swap it. So the element will be 2, here 5, here 4, here 6, because these two elements will be swapped. So 9 and 7. This first pass is literally I have written what is exactly there, and second pass is the actual one which is swapped, started to swap, or else you can write like this: actual values. Okay, first pass is successful and one element is updated, but we know this from this table uh, because we have chosen the smallest element in this one, so we no need to again go and check with the smallest one, so we'll skip it and we'll come to the next. Here I'm picking 5 and I'm updating it as pink color. It's pink or gray color. I'm comparing this index along all this index and I'm finding out which is the smallest. I'm finding it as 4, so I have to swap these two elements. I'm swapping these two. In first one we have swapped this one and this one. In this case we are swapping this one and 4. So what the second pass result will be: 2, 4, 5, 6, 9 and 7. Okay, now we have completed. After this we have 5. Here I'm checking which is the minimum element compared to this. There is nothing, so nothing will be swapped. So I'm writing the same thing: 4, 5, here 6, here 9 and 7. Next pass I'm checking from 6 which is the smallest element with this. We don't have any, So I'm writing the same: 2, 4, 5, 6, and here 9 and 7 is there. So I'm just writing 9 and 7. Okay, now in this case, I'm choosing from 9. From 9, which is the smallest element, of course, the last element. So what I'm doing is swapping these two. So 2, 4, 5, 6, 7, and 9. In 9, we no need to compare it. So that's the last element. So we can just skip it. I'll just delete this row. Remove this row. So we filled our element. The output array is finally sorted. In programming, what you have to understand is which in how to find this index. Here you have this, so you'll swap it. This one you have to find out how do we select this element and how do we swap it. For first condition, you have to iterate every time. So I'm just writing a for loop. So it's there. We have written this for loop outside line number 19. So we'll go until the last element from this element, last to n minus 1 element. So I just need size minus 1 and I have to find the index. So int index, which is nothing but I have to start from I. You know this, we have start from I. The next element will came here and came here and came here and came. So we have to start from I. So what's this J is? You can see this yellow color. We didn't pick it because the whatever the smallest element only we have picked and we have swapped. So we no need to pick the previous elements. So it will be I plus 1. Next element only we have to take, and we have to go until last, because when you conduct a swapping operation, there you no need to compare with the last element where, because there is no element beside of this 9. So that's the reason I have written this size minus 1. Here you have to find out the index, which is the minimum index compared to the active. So the active one is indicated by the index. So what I'm doing is, if condition, here I'm writing ARR of J is lesser than ARR of index, then you just assign this index to J. That's it. You got the minimum index, because whatever the if it is 2 and this is 5, then you will assign that index means just you are picking this numbers 0 to this one, not this actual values. You are just picking this indexes. Then you got where that element is exactly, so you can access that with index. And then if, because if you don't find any also, that's fine. So if you don't find any, you no need to do anything. You can just for in this case, um, we went with 5, but we didn't find any of those elements, so we no need to swap at all. So what I'm adding a condition is index not equal to I, and then I'm swapping. Here you know this third variable swapping, int c equals, you are writing array of, then array of, I'll fill the values, array of, and then AR of You know this index, and here I, here also index, here I, and here also I. You know, I hope you are aware of this third line swap, third variable swapping. What I'm doing is the array index, I'm giving that to next C variable. From whatever there in the array, I am giving to the array index. We have a copy in the C, so we can overwrite this AR of I with this C. That's the reason it will go from this one to left, this right to left, and then top to bottom. This is the standard formula for this. Okay, now once we got the array sorted, we are just printing this. Okay, now I go and copy my input, right click, run the code, paste it. Okay, my array is sorted. From I have entered in the descending order, and here I have printed this from as after sorting. Then successfully the array is sorted. Only the algorithm is this much. Okay, then now we'll meet in the next video. Thank you for watching.